Good morning to you students. Now let us see the problems on Moebius function. Some of the problems I'm going to discuss here. So first of all, let us see this problem. Evaluate summation mu of j factorial where j varies from 1 to infinity. So by j factorial we mean the product of the product of the infinity factorials, or because j here varies from 1 to n. So j factorial here is equal to 1 into 2 into 3 into 4 into 5 dash dash infinity. For example, if you take 2 factorial, what is 2 factorial? It is a product of the first two integers, that is 1 into 4 positive integers, 1 into 2. 3 factorial is the product of the first 3, that is 1 into 2 into 3, and 4 factorial is equal to 1 into 2 into 3 into 4. And what is 1 factorial? 1 factorial is 1. So as you can see here, by definition of mu of j, what is mu of j? Mu of j is equal to 1 if j is equal to 1, and it is equal to 0 if there exists a square which divides j, and it will be equal to minus 1 to the power r if j here is a product of r distinct prime, say p1 p2 dash dash pr. So in this case, as you can see here, for j greater than equal to 4, j factorial, mu of j factorial will be equal to 0. Why? Because what is 4 factorial? 4 factorial, it is a product of the first 4 positive integers, that is 1 into 2, 3 into 4. And as you can see here, there exists a square, that is 2 square, which divides 4 factorial. So therefore, from j greater than equal to 4, mu of j factorial will be equal to 0. So now let us just evaluate summation mu of j factorial. J varies from 1 to infinity. It will be equal to mu of 1 factorial plus mu of 2 factorial plus mu of 3 factorial, because the rest will become 0, because from j greater than equal to 4, mu of j factorial is equal to 0, since it satisfies this definition, second part of definition, that is there exists a square which divides this j factorial. So mu of 1 factorial, it is 1, plus mu of 2 here is 1 into 2, plus mu of 3 is 1 into 2, 1 into 2 into 3. So how many primes are there in this 3 factorial? There are 2, so it will be equal to mu of 1 is 1, mu of 2 is only 1 prime minus 1 to the power 1, plus here there are 2 primes minus 1 to the power 2. So we have 1 minus 1 plus 1. So therefore mu of j factorial will be equal to 1. Now next example is, let n have k distinct prime factors, means n is a product of k distinct prime factors, that is n is a product of p1 to power e1, p2 to power e2 dash dash pk to power ek, where p1 p2 they are all distinct primes. What we need to show is that summation of mu of d into tau of d is equal to minus 1 to the power k. So first of all, let us denote f of n here is equal to summation of, okay, let me write here, capital Fn here is equal to summation of mu of d into tau of d, which is equal to summation of f of d, where d runs over the divisor of n. We can express this where f of d is equal to mu of d into tau of d. First of all, we have to show that this is a multiplicative function. So we claim here now Fn, now f of n is multiplicative. To show that this is multiplicative, if you take GCD of m and n is equal to 1, then what is f of m n is equal to mu of m n into tau of m n. But we know that mu is a multiplicative function, so mu of m into tau of mu of n, and tau also is a multiplicative function, so mu of tau of m into tau of n. So this implies that f here is a multiplicative function. Now this shows that once f is multiplicative function, and what is capital Fn? Capital Fn is called summation of f of d, where d runs over the divisor of n. And what is this summation f of d here? It is summation of mu of d into tau of d, where d runs over the divisor of n. And by the theorem from multiplicative function from the beginning, if this Fn is multiplicative, then capital Fn is multiplicative. So since f is small f is multiplicative, implies that capital Fn is multiplicative by that theorem. Now to show that, to find the formula for this, so we have here what is n? N is equal to, as we have taken it is a product of k distinct primes. So what is f of n? F of n will be equal to f of p1 to the power e1, p2 to the power e2 dash dash k to the power e k. And since f is a multiplicative function, so this can be expressed as f of p1 to the power e1 into f of p2 to the power e2 dash dash f of pk to the power ek, since f is multiplicative. Okay, so this will be equal, so therefore we have, let me write f of pi to the power ei in general. I'll take, where I here varies from 1 to up to k, take the values. So let us see, this is according to definition of f, this is summation of mu of pi to the power ei into tau of pi to the power ei, because fn is defined as this one, and I here varies from 1 to k. So this is equal to, sorry, where I can write here where d runs over the divisor of pi to the power ei. Or I can write in this way, therefore f of pi to the power ei is equal to summation of mu of d, sorry, not this one, tau of d, where d runs over the divisor of pi to the power ei. And here it is, it starts from what are the divisors of pi to the power ei. What are the divisors of pi to the power ei? They are 1 pi square dash dash pi to the power ei. So this is equal to mu of 1 into tau of 1 plus mu of pi into tau of pi plus mu of pi square into tau of pi square dash dash I varies from 1 to k, so and so on. So we have here mu tau of pi to the power ei, tau of pi to the power ei, or ei into mu of pi into tau of pi to the power ei. So this is equal, mu of 1 we know it is equal to 1, and what is tau of 1? Number of divisors of 1, it is 1, plus mu of pi, it is a product of this, since we can express this as a product of single prime, so it will be minus 1 to the power 1. And what is tau of pi? From the number of divisors of pi, what are the number divisors of pi? They are 1 and pi, so it will be 2. And then plus from here, from pi square, mu of pi square onwards, the term will be equal 0, because there exists a square which divides, means there exists pi square which divides pi, so therefore you will get 0 the term. So from here you have 1 minus 2, which is equal to minus 1. So therefore f of pi to the power ei is equal to minus 1. But what is f of n? F of n here, f of n is equal to f of p1 to the power e1 dash dash f of pi to the power ei, f of pk to the power ek. So therefore for I is equal to 1, you have minus 1 dash 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 minus 1. So how many terms are there? There are k terms, so you'll get minus 1 to the power k. So this complete the proof, means summation of mu of d into tau of d is equal to minus 1 to the power k. I hope it is clear to you.